Hello everyone, thank you for checking out my channel, and I want to say that I'm sorry for all my subscribers that took too long of my break to finally uploaded the new video in the problem of constraint motion. Okay, so now without further ado, let's start on working on this problem. So firstly, as always, we read the problem carefully together about this question. So question about the strain motion, and the problem asks us to determine the kinematics relationship between the velocities of cylinder A and B expressed all velocities are as positive in the downward direction. Also determine the number of degree of freedoms present in the system. Okay, so in the constraint motion, as you know, we usually start by identifying that what is the constraint of this system. So the constraint of the system is basically the length of the rope that is attached together. So the rope length doesn't change. It does not extend, neither or slack or compress. So the length is constant in all the time. So we identify that first. So yes, the point for this work is to determine the velocity relation. And of course, like we mentioned, the rope does not stretch or compress. So that means the total length of the rope is equal to L, which is constant. Now, before doing anything else, we must realize that this problem has not one, but two ropes in this question. So I would say maybe this is the rope 1, rope number 1, L1, and here is another one, L2, for example, right? Now, since there's two ropes length, so we must derive two equations. Okay, so firstly, let's go to derive the L1. Okay, so L1, sorry for the color mismatch. Okay, L1 is this green curve here, right? So L1 will be equal to VYB, which is the distance at this datum to this pulley. We call it YB. Okay, and another reason why I didn't use this datum is that I already thought of that this distance from ceiling to this pulley should be constant in all time, right? So since this length is constant, so it will make no sense for us to try to add that as part of the length, because as we know, eventually we will have to uh, do the derivative of the length later on, and all the constant distance will just turn to zero. So it doesn't make much impact in this solving this problem. So anyway, move on. To derive L1, YB is the part of L1, right? But we don't know the distance from here to here, right? What is the portion of the YB that indicate this length here? So that's why we are now looking at the pulley, this pulley in particular, this one, as pulley C, for example. We think that pulley C also have its own movement, meaning that if we pull A down or B down, this pulley C should go up, right? If we pull A down, C should go up. If we pull B down, C should go down, for example, something like that. Okay, so that means we C has to be identified as YC from this datum, YC here. So to derive the rope length L1 equal to YB plus YC, sorry, plus YB minus YC, because we only the rope is going on here and here, right? It doesn't go here. So YB yb will be this lane, yb minus yc will be this lane, right? yb minus yc, yeah. Okay, now that we're done with the first equation, and to just simplify it, we'll get that L1 equal to 2yb minus yc. Now, if we do derivative with respect to time, we get that 0 equal to 2y dot b minus y dot c, meaning that y dot c equal to 2y dot b. So what this is physically means that if we move c, pulley c, let's say downward by 1, oh, sorry, let me rephrase that. So this means that if we move b down by 1 meter, that means pulley C will go down by what? By 2, right? Because it's a portion. If y dot b equal to 1 meter per second, then y dot c will be equal to 2 meter per second automatically, right? So that means the movement of pulley C depend on cylinder B directly. Okay. So now we clear on that. We're going to go on and derive the displacement of the rope of the second rope L2. Okay, L2 is here, right? So L2 will be equal to YA, this length here, YA, and then plus 2YC. Yes, YA and 2YC, because YC only this distance here. Oh, by the way, sorry. Another thing is that the arrow of YC is had to be have at the head of the arrow downward like this. This is not the distance. So if we will make a notion about distance, you should put two arrow like this. Sorry, arrow in both sides. But if you were to mention the distance of the movable object, it should be the arrow should be only one point like here. Okay. Now L2 equal to YA plus 2YC. If we derivative it with respect to time, then it will be 0 equal to y dot A plus 2y dot C. But they ask us to determine the relationship between cylinder A and B, right? They don't want to know pulley C. So we substitute the y dot C equal to y dot B in here. We will get that 0 equal to y dot A plus 4 y dot B. And since we know that y dot is just another term to call velocity of A, velocity of B, then this is your final answer, 0 equal to y dot A plus 4 y dot B, meaning that if I pull A down, sorry, meaning that if I pull B down by 1, by the velocity of 1 meter per second, A will go up by 4 meter per second, right? It's related to each other, meaning that B go down, A will go up by 4 times. Okay. Now this is the velocity equations, but they also ask about how to determine the number of degree of freedoms. So simply say, what is the degree of freedom? In general, in this context, degree of freedom meaning how free is the object in the system. For example, this system has a lot of objects, movable objects, right? If it will boil down into B, cylinder A, cylinder B, and pulley C. There's 3 movable objects. But how free of the system, meaning that how free in a sense is basically the opposite of how dependent, right? Okay, so meaning that if number of degree of freedom is high, meaning that it's very independent, it free, it can move whatever it wants. A high number of degree of freedom means that the high amount of freedom of the movement that the system allow. In the same sense, in the same sense, but in opposite approach is that if the number of degree of freedom is low, that means the system is restricted to a limited allowable movement. If the number of degree of freedom is 1, meaning that only one movement is allowed independently, right? It doesn't mean that it doesn't mean that only one object move in the system. No, it means that only one object in the system is allowed to move independently, while the other object that move have to depend on this one object. Okay, this is like a simple definition. Okay, it's not technically correct, but I want you to understand in the more simple term. So 1 degree freedom meaning that if I pull A down, B and C will move according to movement of A. It cannot move on its own. It cannot act on its own free will. No. If A move, C and B will move with some relation. And it's true in this case because seeing this, look at this equation, for example, yc or y dot c is equal to y dot b, meaning that if y dot b is go down y1 meter per second speed, y dot c will go down by 2. And then since C depend on B and A also depend on B as well. You see what I'm getting at? That is, in this example, we pull down B and C move according to B 2 times. Then A move opposite side of B 4 times, meaning that everything is depend on B. So B has independent allowable movement, only one in the system. But it's not restricted to only B. You can use the same logic with A, either A or C. You can push A and B. You can, for example, you can push A up by, let's say, 1. Then B will go down by 1/4, right? Then if B go down by 1/4, then y dot c will be what? Y dot c will be 1/2 in the same direction with B. Something like that. Please check the number again. I'm not so sure. But the point is the same, that one movement is allowed to be independent. The rest is going to have to go along with that movement. Either B, A, or C. You have to pick one, B, A, or C. If B move independently, then A and C follow B. If A move independently, then B and C depend on A. If C move independently, of course, A and B will have to follow C. And that is the easiest way that I can explain to you about the number of degree freedom in this context. But don't worry, there will be more examples to come in future that we can talk and discuss about this degree of freedom concept together. Okay, so today, and thank you all for your time and your attention. I hope you learned a few things from this video and use it apply to your homeworks or your exam, and maybe just you just know more new things, and that is a successful feedback for me already. That I know that someone out there learn this knowledge and make good use of it. Okay, thank you so much for your time, and see you on the next video. I promise that I will be more active in future about the teaching material. Thank you so much for your support again. If you like it and if you're new to this channel, please feel free to subscribe on the channel and leave the comment of what is not so clear, what is that you still confusing or want to know more. Please feel free on the comment. I'm happy to look onto every comment that posted. Thank you for your time.